A ball 1 is dropped from rest from an initial height h. At the same time, ball 2 is launched vertically upwards at an initial velocity u. At what time are both balls at the same distance above the ground? So it's asking, in this case, we can see that they want the time. So ball 1 starts off at height h. These are the equations of motion from the IB Physics Formula booklet, and you can see this from 8.1. So let's start with the first ball, and we can deal with each ball specifically. For the first ball, we know that it's h, and since it starts from rest, we know that the initial velocity, i.e. u, is equal to 0. The acceleration would be g. G would be positive, because the velocity would be increasing as it falls. And we're going to let the displacement, the total displacement, it's going to be the height minus x. And x is basically just the distance traveled, and it's going to make it easier to solve the future things. So, because we know the relevant factors, and what we need is time, so we can write that t is equal to what? Well, so we need to find the equation which has u, s, i.e. displacement, a, and t. That would be the third equation, s equals ut plus half at squared. And a reminder, because of x, we're going to write that x is equal to ut plus half at squared. Now, of course, because we know that u is equal to 0, this whole term will equate to 0. So we can write that x is equal to 1 over 2 gt squared. So that means is that the displacement would be, since it's h minus x, that would be equal to h minus half of gt squared. So now we need to deal with the second ball. Now, the second ball is launched vertically upwards at initial velocity u, so it's not from rest. And it's not given any extra displacement. You can see on the graph it starts at 0, 0. So we can write that the acceleration is equal to minus g, because the velocity will be decreasing with time. The initial velocity here, this is equal to u, but here u is just a value unlike here, so it's just a random variable. We have a, and then in this case we'd be looking for the displacement. Let the displacement of the second ball be big D, and then of course we want the time. So for these specific parameters, we want to use the initial velocity, the acceleration, the time, and the distance. So again, this would be best suited for the third equation. So we can write that d, i.e. is equal to ut plus 1 over 2 minus gt squared. So this is the larger displacement. So now that we have this displacement in general, we can see that they want the time when they're both the same distance above the ground. So now we have the displacement for both of them, i.e. it would be when h minus x is equal to d. And now we have these two equations from here. So we can write, and now if you have a key and I, you can see that these will be cancelling out. So finally we get that h is equal to ut, and to define in terms of t is equal to h over u, which corresponds to option C.